Good morning class 11th. बेटा we are doing vectors और आज हम पढ़ने जा रहे हैं how to resolve a vector in its components. Before I start you giving concept of components, I want to make you feel what does it mean by component of a vector. For that I am showing you a simple normal day life experiment. See, here an arrow is made to show the motion of an object, right? Now I'll use a light matchbox and I'll pull it with help of this thread. Focus on the simple concept and the analysis. This object is at rest. I use this thread to pull. Pull means exerting force. And I think you can easily understand that when I am pulling this object using this thread, then my pull is along the thread, this tight thread, because when I will pull this thread, this matchbox will start moving in the direction of pull. Can you see it? When I will pull this matchbox will start moving towards the pull. And in which direction I am pulling the matchbox? I am pulling the matchbox along the length of my force is applied along the length of this thread. Are you getting this point? My pull is along the length of this thread, right? And this object is moving. Now pay attention. I am pulling this object along the length of the thread, and you can see that my thread is not horizontal. I am pulling this object at some angle, right? I can pull this object in horizontal direction also. So since my force is in horizontal direction, so the object is moving in horizontal direction, easy. But if I apply my force at some angle, see, then also this object is moving in horizontal direction along the arrow. But I am applying my force along this thread. So why this object is moving along the arrow? Now here a very important concept is involved. And what is that? That the force which I am applying, that force has its effect in this horizontal direction also. Listen to me again carefully. The direction in which I am applying the force. This pencil is in the direction of force. You can take the pencil to represent force vector, and this pencil is along the length of the thread. Now this pencil is the force applied, but the object is moving in horizontal direction. So can I say that this force vector, which is represented by this pencil, has some effect in this direction also? That is why the matchbox is moving along the horizontal direction while my force is not along the horizontal direction. It is at some angle theta. And now if I increase the angle at which I am applying the force, see, This is horizontal, a small angle, and now I am increasing my angle. I am increasing my angle, and you can see that if I increase my angle, then I can lift this matchbox also. I don't know whether it is visible to you or not, but the matchbox is lifted up. It is moving horizontally also. Can you see the matchbox is lifted up if I am increasing the angle of the thread? Now this matchbox is moving horizontal also, and it is showing its displacement in vertical direction also. I want you to feel this point, that actually when I am applying the force along the thread, then this force, which is at some angle on the object, is having its effect in horizontal direction also and in vertical direction also. The horizontal effect is called horizontal component of this force vector. The vertical effect of this force, or effect of this force in vertical direction, is called vertical component of the force applied along the thread. Applied along the thread. This is actually the direction in which the force is applied. This black pencil is force vector, and the tip of the pencil is direction of the force vector, and the tail of the pencil, this is the point where this force is applied on the object. So finally, what is conclusion, beta? Conclusion is that if we apply a force on an object at some angle theta from the horizontal, then also the object shows motion in the horizontal direction. Object shows motion in the horizontal direction, this direction. And this motion shows that although force is applied at some angle theta, but this force has its effect in horizontal direction also, and that effective part of the force is pulling this object in horizontal direction, in the direction of motion. Since this matchbox is quite light in weight, so when I increase the angle theta, the vertical component also appears in the picture. The vertical effect, or the effect of the force in vertical direction, comes into the picture, and this matchbox shows its deflection or displacement in vertical direction also, because the weight which is acting downward is very small in case of the matchbox. But if I use a heavy object, now I am pulling again this heavy object with the help of the thread. See, I am pulling it. It is having the motion in horizontal direction. So that means the pull which is along the direction of thread at some angle theta has its effect it is showing its effect in horizontal direction, and the object is moving in horizontal direction. But now if I try to increase the angle also, then also this object will not show deflection in vertical direction. although this force is having its effect in vertical direction also, but this weight of this object is quite heavy. So this vertical component or vertical effect or force, effect of force in vertical direction is not sufficient enough to pull this object in vertical direction. So through these two experiments, we got a very, very important concept. What is that concept? That a vector quantity has its effect in horizontal direction also, in vertical direction also, although the vector actually is acting at some angle theta from the horizontal. So the effect of a vector quantity experienced in horizontal and vertical direction, actually it is not only horizontal and vertical direction, it can be in any two directions, but in our course the two directions will be mutually perpendicular, and since we have to deal with the simple cases only, so we can say that it is along x-axis, the horizontal direction, let me say that it is along x-axis, and the vertical direction, let me say that it is along y-axis. So effect of force in two mutually perpendicular directions is called component of a vector quantity in this direction and this direction, or I can say component of vector quantity in x-axis direction and in y-axis direction. And we represent the component of this force in x direction as Fx and in y direction as Fy. Now tell me if you are feeling some, I am not saying that you will be exactly clear about the concept of components, but are you able to feel the concept of component a little? That a vector quantity has its effect in other directions also, and that effect is actually represented by a name called component, right? So let me start discussing component of a vector. Dividing the vector quantity in its components is called resolving a vector. Dividing a vector quantity in its components is called resolving a vector. Now let me come to that vector which we discussed in the previous classes. Do you remember we discussed position vector? I told you that if I start moving from origin, I move x unit along x-axis, then I move y unit along y-axis, and then I reach to a point P. Then you know that my coordinate of the position will be x and y. And I told you that I can write my position using the position vector r, and r can be written in terms of unit vector I and j as x coordinate into I cap plus y coordinate into j cap. And I told you, I explained to you in the last class that magnitude of this position vector will be under root x coordinate square plus y coordinate square. And the tan theta, that means direction of the position from x-axis, tan theta can be written as, just consider this yellow triangle, perpendicular upon base, y upon x, y coordinate upon x coordinate, right? Now this whole discussion, I am doing the whole discussion, now I am moving in just reverse direction. here I moved x, then I moved y, and then I reached at P, and then I have written then I wrote the position vector r. Now I am saying that I am already given the position vector r. Say, take any example. I am given the position vector r as, say, 3i plus 2j, right? And I am asking you, tell me the x and y coordinate. We practiced this problem in the last class, and you will say that 3 is the x coordinate and 2 is the y coordinate. Now let me explain you a method also. What is that method? That I have this vector r, I'll drop a perpendicular from the point P on x-axis, and I'll drop a perpendicular from P on y-axis. On x-axis, the perpendicular touches the x-axis at n, and I got a length ON, which is x unit in x-axis direction, and I got a length OM, which is y unit in y-axis direction. Are you getting this point? What I did? I dropped a perpendicular from point P on x-axis and from point P on y-axis, and I got this length ON and OM. This ON is known as projection of vector on x-axis. Listen to me carefully, these technical words. This ON length is called projection of vector OP along x-axis, and this length represents effect of this vector OP. Now it's not compulsory or necessary that this is position vector only. It can be a force vector which we were using in the experiment. So this ON is projection of a vector along x-axis and is known as component of vector along x-axis. And this OM is projection of OP along y-axis and is known as y component of vector OP. So what was the method to find the component? It's exactly same as I was using to find x coordinate and y coordinate. The same way actually I am using the concept to find x component and y component. If you take the position vector, any general vector. Now let me see that how we are going to calculate this length ON and OP, right? So after dropping the perpendicular from the head of the vector on x and y axis, just consider the yellow triangle. In that triangle, can you see that cos theta is base upon hypotenuse? That means base is length x and hypotenuse is magnitude of vector r, because magnitude of vector r is represented by length of the vector. So x upon magnitude of vector is cos theta. So the x length, which is known as projection of vector on x-axis, or x component of vector, so this x, which is also known as x component of vector, is actually the magnitude of the vector cos theta. Now here the thing which we have to remember is that x component or cos component, not x component, actually cos component of the vector is that vector. Cos component of the vector is that component which is making angle theta with the vector. Because every time we are not going to use trigonometry and we are going to write all this. We will directly say that the component which is making angle theta with the vector is cos component. And just look at sin theta here. Sin theta is perpendicular upon hypotenuse. So sin theta is perpendicular, that is, now see, the length OM and length this which is represented by the y, they are same. So this y component or projection of vector on y axis is represented with this length y, and sin theta is y upon magnitude of vector r. So sin theta is y upon magnitude of vector r. So y is magnitude of vector r sin theta. So projection of vector on y axis or component of vector, y component of vector is r sin theta, or we can say that the component which is not making angle theta but making angle 90 minus theta with the r. The component which is making angle 90 minus theta with the vector is always sine component, and component which is making angle theta with the vector is always cos component. Is it clear that how we resolve a vector in two components? By dropping a perpendicular and using trigonometry, we will have a sine component and a cos component. So this is the way how we calculate component of a vector. Now in the next class, we are going to discuss this whole concept in detail when it is in 3 dimension. Right? Position vector is generalized in any general vector A, and we are having sine component of vector A and cos component of vector A. And now in the next class we will discuss when the vector has 3-dimensional orientation, right? So if you are getting the concept, इतनी बात समझ आई है तो मुझे फीडबैक दो बेटा, either in comment section or by liking the class and subscribing the channel. You can get notifications. Press the notification bell so that whenever you are having 11th class uploaded, you will be notified that your class is uploaded, your topic is uploaded, and you can go through the topic. The books I am using for discussing the questions is Newton Physics and H.C. Verma, and you can also use, because I take the questions from NCERT also. So these are the 3 basic books which I am taking, and the way I explain the topic is, first I explain the topic according to a child who is not, I suppose that the child is not very clear in the concept, so I try to explain it in easy language, in slow pace, and after that I'll discuss, this is my way, that discuss lot of numericals, lot of problems, because according to me the problems, solving the problems is the only way to get the concepts of physics. तो बेटा मेरा हमेशा कहना है, सपने ऊंचे देखो, मेहनत करो और ऐसा कुछ करो कि लोग गर्व से तुम्हारे नाम के साथ अपना नाम जोड़ना पसंद करें. So all the best children.